Hey guys, my name is Varun and I welcome you to another video of We Teach Math. In the previous video, I had tried to explain this example question but I could not complete it. I sincerely apologize for the same, and today I would like to start by explaining this question from scratch so that we all get this clearly in our heads. Let's read the question. We have to find the number of different signals that can be made by arranging at least two flags in order, one below the other on a vertical staff, if 5 flags are available. So we have a total of 5 flags. So we have to find the number of signals with each case starting from 2 flags till 5 flags. That means, to put it clearly, we have 4 cases. Case 1 is making a signal with 2 flags. Case 2 is making a signal with 3 flags. Case 3 is making a signal with 4 flags, and so on. So the flags are stuck to a vertical staff, that is the staff is straight and the flags are stuck one after the other from top to the bottom. Alright, okay, so I think I made the question clear. Let's start at case 1. Number of flags for one signal is equal to 2. First case is we are using 2 flags. Okay, so guys, we have to find the number of different signals with 2 flags for case 1. So there are certain ways to do a job, right? So now the job is making a signal. So the number of ways of making a signal is the same as the number of signals made, because each way or each method to make a signal, if used, give a unique signal which is different from the others, right? So the number of ways or methods to use the signal is equal to the number of signals, number of possible signals. Let me note this down. Number of ways or methods or arrangement of flags. This is the question. If you arrange certain number of flags, you get one signal. Alright, so number of arrangements of flags is equal to number of signals. So guys, this is just for explanatory purpose. This step is not necessarily needed in the answer. Alright, okay. So the number of ways, or you can call it methods or arrangement of flags, is the same as the number of signals. So the job is making a signal. We have to find the number of ways to make a signal. Alright. So we have number of flags for one signal is equal to 2. So the job is divided into 2 steps. Step 1 is choosing a flag for flag 1. And step 2 is choosing a flag for flag 2. So number of options or ways for flag 1. Number of options or ways to choose flag 1. So step 1 is choosing flag 1 is equal to 5, because there are 5 different options, 5 different flags. So that means you have 5 different ways of obtaining a flag for the position of flag 1. Number of options or ways to obtain flag 2 is equal to 4. So one of these 5 flags has been used up for the position of flag 1. So we have remaining 4 options. So that means we have 4 different options to obtain a flag for the position of flag 2. So these are 2 steps. Let's name this step 1 and let's name this step 2. And so in a job, so the number of ways to complete or to do a job is the product of the number of ways or methods for each of its steps. Is the product of the number of ways for each of the steps. So there are 5 ways for step 1 and 4 ways for step 2. So number of ways, or let's say number of signals. You need to always write number of signals. In the previous range I had in the previous page I had written number of ways to obtain a signal. That's just for explanatory purposes. You need not mention that in actual answer. So number of signals is equal to 5 into 4 is equal to 20. This is case 1. Similarly, let's go to case 2. Case 2, number of flags for each signal is equal to 3. So we need 3 flags for one signal. Total number of flags is equal to 5. As I said before, we divide the job into 2 steps. We divide the job into steps. So since there are 3 flag positions to be filled, it is divided into 3 steps. Step 1 is filling the position of flag 1, step 2 is filling the position of flag 2, and step 3 is filling the position of flag 3. So let's start with step 1. Number of options for flag 1 is equal to 5. Because there are a total of 5 options, you can choose any one flag out of the 5 options for filling up the position of flag 1. So one of these 5 flags get used up for the position of flag 1. Let us go to flag 2. Number of options for flag 2 is equal to 4. So we have 4 remaining options for flag 2 as one of them has been used up for flag 1. And for flag 3, please just write number of options. I'm too lazy to choose. Number of options for flag 3 is equal to 3. Because 2 of them has been used up for the positions of flag 1 and flag 2. So as I said, the total number of ways to choose a flag, total number of ways to choose to make a signal is the same as the total number of signals generated. I had mentioned this earlier, explained it as well. So just write total number of signals. Total number of signals is equal to 5 into 4 into 3, that is equal to 60. Right? Similarly, for case 3, we divide the job into steps. Now since we have the position of 4 flags, we divide into 4 steps, filling up flag 1, flag 3, filling up all the 4 positions. Alright. So as I said as I explained it earlier, do the same steps but divided into 4 different equations for flag 1, flag 2, flag 3 and flag 4. And if you do that, for the position of the first flag you'll have 5 options. For the position of the second flag you have 4 options. For the position of the third flag you have 3 options, and position of the fourth flag you have 2 options. That is equal to 120. Guys, don't do like this in any of the question, explain it detailedly. I'm just doing it because I've explained it earlier and I want to go a bit faster. Case 4. Case 4 again. First position has 5 options, second position has 4 options, third position has 3 options, second position has 2 options, and the first position has fourth position has 2 options, and the fifth position has one last option. 5 into 4 into 3 into 2 into 1, we again get 120. Now the question is, find the total number of signals if the minimum number of flags is 2. That means we have to find the sum of all the number of signals in each of these cases. That means total number of signals generated. We have to find the total number of signals generated. That is equal to 120 plus 120 plus 120 plus 60 plus 40. is equal to 340. Yeah. Apologies, it's 320. This is not 40 but 20. 320. Now I've explained this example. Let's move into the NCERT exercise 7.1. So guys, let's start the exercise 7.1. The questions, I'm not going to do all the questions, but a few of the questions which need explanation. If you're clear with these questions, the remaining questions you can do on your own. So let's start with the second question. The second question is, how many 3-digit numbers can be made? Apologies, how many 3-digit even numbers? 3-digit can be made from digits 1, 2, 3, 4, 5, 6 with repetition. So guys, we have positions for 3 digits. All right, so that means we have 3 steps in the job of finding a 3-digit number. The first step is filling up the 100th place, the second step is filling the 10th place, and the third step is filling the 1th place. So repetition is allowed here. That means we have 6 options for the 100th place and the 10th place. Because repetition is allowed, we can have any of these 6 digits in the 100th place and the 10th place, because the options doesn't decrease as we flip the position, as repetition is allowed, right? Okay, let me explain this better. 100th place, 10th place, and 1st place. So in 100th place we have 6 options. Since repetition is allowed, the digit which has been used in the 100th place can be used in the 10th place. So that means we still have 6 options. The number of options doesn't decrease by 1 for filling up the 10th place. Alright. And so that means number of options for 100th place. Number of options for 10th place. 100th place is equal to 6. That is the same as number of options for 10th place. As these 3-digit numbers are even numbers, the position of the 1th place can be filled up only by even digits, that is 2, 4 or 6. So number of options for one place. That is 3. So the total number of 3-digit numbers, 3-digit even numbers is 6 into 6 into 3, that is equal to 36 into 3, that is equal to 108. Okay. Now the third question is quite similar, except the question is, let me read it for you. How many 4-letter codes, guys? The 4-letter code means word. They're asking for a 4-letter word over here. Alright, let me write it for you. 4-letter word can be formed using 10 letters of English alphabet. if no letter can be repeated, that is, repetition is not allowed. Just like the previous other questions, we have to multiply the number of options or number of ways for each step. So the first step is filling up the first position of the first alphabet. We have 10 options. Since no alphabet can be repeated, the number of options decrease with increase in number of options decrease as we fill up each position. First position has 10 options, second position has 9 options, third position has 8 options, and the fourth position has 7 options. 10 into 9 into 8 into 7 is equal to 720 into 7 is equal to 5040. Guys, I'm not going to detail into steps, I just care about the explanations. If you want to have the proper steps, please refer the net, or I will try to upload the answers with steps on a different website, and I'll share with you as soon as possible. From the very first video, I have not been focused on the steps. I've been focused on explaining the question and logic to you. Please do not use the steps on your answers and refer the steps on the net, or I'll try to upload the answers through you and share it with you by any means possible. Please bear with me for a while. Moving on, let's go to the fifth question. How many 5-digit telephone numbers can be constructed using digits from 0 to 9 if each telephone number starts with 6, 7 and no digit appears more than once. Meaning there's no repetition. So the question here is, how many 5-digit telephone numbers can be constructed from the digits 0 to 9? So there's a total of 10 digits including 0. So starting from 0 and ending at 9, there are a total of 10 digits. If each telephone number starts with 6, 7 and no digit appears more than once. Apologies, there's a mistake here. So that means there's a 5-digit telephone number. 1, 2, 3, 4, 5. So the job is finding a 5-digit telephone number. We have to find the number of ways we can make a telephone number, alright? Because the number of ways of completing job, what I meant was the number of ways of making a 5-digit number is the same as the number of existing 5-digit numbers, because each way of making a 5-digit number, or each method to make a 5-digit number, or each arrangement of 5 digits give a different number, right? It gives a different and unique number. So the first 2 steps I've already made. The 5-digit number starts with 6, 7. So out of the 10 digits, 2 of them has been used. There are remaining 8 left. So there are 8 options for filling up the 3rd digit, 7 options for filling up the 4th digit, and 6 options for filling up the 5th digit. Right? So we have to, for the number of ways of finding a 5-digit number, we have to multiply the number of ways of each of its steps. So there are 3 steps here. Number of ways of doing the first step is 8. Number of ways of doing the second step is 7. Number of ways of doing the third step is 6. Since these two there are constant digits over here, there's only one way, because there's only one option. Alright, 6 and 7 are the constant numbers are the constant number in every 5-digit number. Apologies, I meant the 6 and 7 are the constant digits in every 5-digit numbers. There's only one and only one option for 7, that is 7. There no other digit can take its place. The same goes for 6. There's only one and only one way or one option to fill up the position here. So that means the number of ways of making a 5-digit number is 1 multiplied by 1 into 8 into 7 into 6 is equal to 56 into 6. 6, that is 336. Now the fifth question is extremely easy. I don't need to do this for you. You can do it on your own. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? As you all know, this is common knowledge. A coin has 2 sides, heads and tails, and any of these outcomes are equally possible in each time. That means the options can be repeated. Alright, so there are a total of 2 options in each of the 3 types, heads and tails. So that means the answer is 2 cubed. There are 8 possible outcomes. Let us move on to the 6th question. 6th question I have already done an example, so you can again do this on your own. Given 5 flags of different colors, how many different signals can be generated if each signal requires the use of 2 flags one below the other? This is part of the example question of, please do this on your own. You can refer to the answer on the net, or I'll upload the answer key and I'll share it with you as soon as possible. Let's move on to the next concept, that is factorials. Now factorials are nothing but products of progressively decreasing numbers. Starting, and the multiplication process starts from any number, any random positive number. Factorials are represented by the symbol n factorial, where n is any positive number and this exclamation mark represents that it's a product of progressively decreasing numbers. Each number in this multiplication process decreases by 1. Let me give an example. Let's say n is equal to 5. N can be any positive integer. Let's take 5. 5 is a positive integer. 5 factorial. So the factorial is 5. That means the product is 5 into 4 into 3 into 2 into 1 multiplied by 1. As you can see, each number in the multiplication process steadily decreases by 1, and finally the multiplication process ends with 1. This is the case with any factorial. You can start the multiplication process with any positive number, but you have to end the process with 1. You can't continue the multiplication process less than 1. So 5 factorial is equal to 20 into 60 into 2, that is equal to 120. Okay. Now I hope the factorial concept is clear in your heads. Let's start with permutation.